Imagine your mobile app pushing a critical security update to millions of users, only for older devices to crash because they can't handle a new API response. Or your latest app version expects fields that your old API simply doesn't provide. This, my friends, is API versioning gone wrong, the silent system killer that turns evolution into chaos. Today, we're going to master the art of evolving APIs without breaking everything. We'll explore strategies that keep global services like Netflix streaming to billions while continuously deploying new features. By the end of this lesson, you will be able to understand battle-tested API versioning strategies and their hidden trade-offs. You'll learn how major platforms ensure backward compatibility at an immense scale. We'll discover production patterns for zero downtime API evolution, ensuring your systems remain robust and available. And finally, you'll identify critical monitoring strategies that prevent versioning disasters before they even start. Get ready to transform your approach to API evolution. Let's dive into the core strategies for API versioning, each with its own trade-offs. First up is URI path versioning. This is often the most obvious choice, as seen with GitHub, where API versions are explicit in every request, like /API/v1/users. While simple and visible, it can lead to URL proliferation, meaning every endpoint multiplies by the number of versions. The hidden insight here is that it works best when you version entire API surfaces together, not individual endpoints. Next, we have header-based versioning, often considered the professional choice. Pioneered by companies like Stripe, this allows clients to request a specific API snapshot from a particular date or version. This enables fine-grained control and gradual migration. The crucial pattern here is to use semantic versioning for breaking changes and date versioning for backward-compatible evolution, offering both stability and flexibility. Finally, there's content negotiation. This REST purist approach embeds version information directly into media types, like application VND company user v2 plus JSON. Twitter's API v2 uses this to maintain clean URLs. The non-obvious complexity here is that it requires more sophisticated client libraries to parse and understand these media types, adding cognitive overhead for API consumers. Each strategy has its place depending on your system's needs and your audience's capabilities. While choosing a versioning strategy is important, the real complexity often lies in managing the transition. First up is the thundering herd problem. This happens when you announce a hard cutoff date for deprecating an old API. Netflix learned this the hard way when millions of devices tried to upgrade simultaneously, overwhelming their systems. Instead, you need progressive deprecation, gradually reducing the performance of old versions while monitoring migration. Then there are schema evolution challenges. These are insidious bugs. Adding required fields breaks old clients, removing fields breaks new ones, and changing types can silently corrupt data. Amazon's solution involves schema registries with compatibility rules. Every schema change is validated against matrices to ensure both forward and backward compatibility, meaning new schemas can read old data and vice versa. Finally, version transitions create unique failure modes, so circuit breaker integration is crucial. Google Cloud integrates version-aware circuit breakers that fail gracefully between API versions. If v2 starts failing, the system can intelligently fall back to v1, preventing a full outage. These proactive measures are essential for robust API evolution. Let's explore how industry giants approach scalable API evolution, offering valuable insights for your own systems. Netflix, with its 2,000-plus microservices, practices evolutionary architecture. Their key insight is to version at the contract level, not the service level. They use packed testing to ensure consumer-driven contracts remain unbroken. A critical pattern they employ is parallel run testing, where new API versions process real traffic alongside old ones, comparing responses to catch regressions before full migration. Stripe offers time travel APIs through their date-based versioning. This allows clients to request API behavior from any historical date, effectively creating an individual API timeline for each integration. Their secret? sophisticated compatibility shims that translate modern internal APIs to historical external contracts, providing unmatched stability. Shopify, when deprecating their V1 APIs, used graceful degradation. Instead of hard failures, old endpoints returned increasingly limited responses, gently guiding users toward migration without breaking existing workflows. Crucially, all these strategies rely on robust monitoring client behavior. Don't just track server metrics, monitor version distribution, error rates by version, performance impacts, and most importantly, migration velocity. Understanding how quickly clients adopt new versions and which features they actually use is paramount to a successful evolution. We've covered a lot of ground today, from foundational strategies to advanced production patterns. Let's quickly review our journey. We started by understanding the core versioning strategies, URI path, header-based, and content negotiation, and discussed their unique trade-offs. You now recall critical patterns for migration and schema evolution, including how to avoid the thundering herd and manage schema changes with registries and circuit breakers. We also explored how leading companies achieve continuous evolution, drawing lessons from Netflix's evolutionary architecture, Stripe's time travel APIs, and Shopify's graceful degradation, emphasizing the importance of monitoring client behavior. Before you implement API versioning, remember this production checklist. Define your compatibility guarantees upfront, establish clear deprecation timelines, implement comprehensive monitoring, create automated compatibility testing, and plan your migration tooling before you need it. The path forward is to start small. Implement header-based versioning for one endpoint and measure the operational impact. The key insight is that versioning isn't just a technical decision, it's a product strategy that affects every client interaction. And remember, the best API version is often the one you don't need to create. Always explore additive changes and feature flags before introducing a new version. For your self-assessment, how would you design a deprecation strategy for a critical API used by millions, ensuring minimal disruption?